October 20th at 12:20 a.m. Preeti Somal, SVP of Engineering at Temporal, got a call. AWS was going down, US East-1. Temporal's customers kept running. The software was healthy, all because Preeti and her team had built 3 layers of reliability before this incident hit. For everyone using AWS, Azure, or GCP, it's not a question of if, it's only a matter of when. I'm Suresh Mathew, your host. Welcome to One Idea. Welcome, Preeti, to the show.
Thank you, Suresh, and thank you for having me on the show. Looking forward to chatting today.
Absolutely. Okay, so the first thing first, Preeti, walk us through the first few moments of that call, that 12:20 a.m. call, and what were the conversations? How did you guys respond and resolve this?
I think the first few minutes of it is mainly trying to orient yourself towards what is happening, right? And in this particular case, the magnitude of the impact was a lot. And so, just trying to comprehend, okay, which of the AWS services are not functioning and what is the impact that we would see. Now, we detected this by our own monitoring. One of our principles is that we detect and start an incident before our customers do, so we can proactively notify them. Um, and so as soon as we kind of discovered this was happening, we got on the Slack huddle and we were working through what the impact is. The first thing we do when we determine that impact is update our status page and start informing customers proactively. In that incident, the first phase of the incident, a different set of AWS services were impacted. Our impact in the first phase was only on our control plane. However, sort of later in the morning is when sort of the
Data plane.
Exactly. And that's where the network load balancers, starting up new EC2 instances, etc., started getting impacted. And so when that happens is when we then start actively moving into failover mode. And that's where we started activating the multi-region failover for our customers so that we could sort of almost evacuate them from US East-1 and move them to a different region so that they can be their service can continue operating without any impact.
Was it a slow ramp or the cutover was like immediate?
There were a number of customers that had already detected the data plane path issues, and they had already
moved.
Exactly. And then for the rest, our failover started kicking in. It's minutes. It's very, very fast. However, there were a subset of namespaces, a small number of namespaces where we ourselves hit network path issues. And so in that case, as soon as we found that, we ended up having to shift into manual mode. And then we started failing over those namespaces manually.
I see. This is where the command line helped and
Yes.
not using the
Not using the
Uber
tool.
tool.
Yes.
Okay. And this is a homegrown tool, I'm assuming.
Yes.
From a metric standpoint, right? So what was the first indicator or the lead indicator of this failure? What was the metric that said, you know what, something is wrong?
So for the 1220 incident, it was essentially some of our canaries that sort of test the control plane. And then for the second phase of it, we also have canaries that hit our data plane. And so when those start alerting, as well as system metrics, I forget exactly which system metric triggered for this, but we start seeing either latencies increasing
I see.
or, the
early signs of something going wrong.
Because we've invested so much in our observability and alerting, we pick up sort of the early signs very, very quickly. In fact, we've had situations where we have picked something up and then we've gone to like the status pages of some of like AWS or GCP
And inform them.
Yes, I mean they are probably aware, but their status page still hasn't been updated. So sort of the early early warning system for us is very well tuned.
Be it AWS, be it GCP, be it Azure, right? It's never a question of if, it's a question of when. It's bound to go down tomorrow. Now, for you, the metrics were, I'm thinking, light a little bit, right? How did you figure out where was exactly the problem and how did you manage to pinpoint the areas that you need to fix?
So, as folks who kind of trapped this incident know, it was a fairly complex and multi-phase incident, right? It lasted almost 16 hours before AWS kind of was fully up and functioning in US East 1. So for the first phase of it, the services that were impacted were really just sort of impacting some of our control plane, which means that our customers were still up and running and no issues there. And so for that, we basically look at, okay, can a customer create a new user? These are sort of operations that are mission critical to their applications that are running. Now, the next phase is where it got really intense because this is where the network load balancer started getting impacted and we couldn't create maybe EC2 instances and things were really starting to go downhill pretty fast. So the first thing we do, and this is sort of the culture of reliability that we have, is we've got this capability called multi-region failover. And this was built specifically for a scenario like this, right? And so part of the temporal sort of value proposition is think about all failures that can happen. And failures will happen, as you said. But the main thing is, can your code keep running as those failures happen, right? And so as soon as we realized that customer traffic is starting to get impacted, we flipped into a failover mode where we started failing over these namespaces into the second region that was configured for them.
Tell us what exactly is a multi-region failover? How do you trigger it? How do you build a system that has this feature?
Some basic concepts before I can explain that is within temporal, you have the concept of a namespace, which is where the customer's workflows run. And then the customer has the concept of a worker, which is where their code runs. And what temporal is doing is these workflows that run within temporal, it's orchestrating code that is running in the workers,
I
right?
see.
And that's how we keep track of where the workflow is, what state it's in, and that's how we can replay it and really sort of recover from any errors. Now, within temporal, we have this capability called multi-region replication that lets us replicate what's happening in that namespace in one region to another region
With three AZs.
with three AZs or even to a different cloud, right? And so that's what we call multi-region replication. So let's say you're running your application, it's running on temporal, you've enabled multi-region replication. What that means is that you're constantly replicating to a very, very hot standby. And when a failure happens, you can trigger your workers to connect to the replicated namespace. And all of this can happen within seconds and you can be up and running with no impact on your system. So
Got it.
that's what multi-region failover entails.
Can we make it such that even the clients or the customers do not have to switch to the other one? Can we have some DNS that is pointing to the other one too?
So we handle the DNS failover part as well.
I see.
And then we have best practices around because the workers are run by customers, right? And so obviously if they're in the same region, so we basically will share the best practices around running workers in both regions, how the DNS failover happens. All of that is pretty well automated. And the trigger for this failover can be either human driven, a customer can come into the UI and say, okay, failover now, which is what with the drills and the game days is used, or it can be triggered by the automated health checks.
From a basic standpoint, right? I think this we can probably have active.
Exactly. If you want to map it to like industry specific terms, it's really active passive, but the switchover, the failover is incredibly fast.
And the max loss is a minute.
Yes.
And you can pick up from, you have milestones and you can start from anywhere.
Exactly. And then we will do any conflict resolution if anything was missed in that replication lag.
I see. The failover happens when the system picks it up. The loss during that time,
If any, we will go back and we will resolve it.
you had a heavy dependency on the network load balancer in that process.
So this was a really interesting incident for us to learn as well. So what happened is, if you remembered, the network load balancer failures were also a bit erratic, right? And so one of the failover tooling paths that we use, the network route for that failed. And when that failed for a small set of sort of customer namespaces that needed to be failed over, we ended up having to sort of drop into more command line mode versus automated mode. And so that was one of our big learnings that came out of that is we went and we assessed our entire failover stack and made sure that the trigger for the failover doesn't use the network paths and or has alternate sort of approaches where we can be much faster in failing over.
Help me understand the dependency there. So there was a dependency on a load balancer, and this was a tool depending on the load balancer?
Yes.
Oh, I see.
The tool that so the replication doesn't depend on it. Replication is happening. The tool that actually
The controller tool.
exactly during the outage, what happened is a number of our customers that were already using multi-region replication and had their own monitoring going and detected the incident was happening, they failed over themselves and there was no issues. Things worked really well. And then for a small subset of namespaces, we ended up hitting this one particular scenario that we hadn't accounted for in our failover tooling. And that then caused us to, every time you fall into manual mode, it takes longer, right? So it took us longer to fail over a few of these namespaces. And that was one of our biggest lessons learned. And, again, I think from a culture point of view, one of the things about temporal when an incident happens and when we do root cause analysis, we are completely transparent with our customers around the flaws on our end as well. And this is one of the big ones that we found that we have since fixed.
So I'm assuming it was an exercise of what were the things that were done manually,
Right.
what took longer,
Exactly.
and say what were the flaws are.
Exactly.
And how long did this whole exercise take?
So, in the case of the ones that we had to fail over manually, it took us up to about 35 minutes to fail over. We want to do better for sure. And this was a good learning for us coming out of the incident as well.
Now coming back to the culture point, right? So you started establishing this gig day, right?
Right.
Where people exercise what is the deal and give us more.
So one really interesting thing, Suresh, that came out of this incident is all of a sudden everybody realized that these failures can happen, right? You and me know that these happen, but
Yes.
when it actually happens is when a lot of people realize that they have to be better prepared, right? And so it's been really interesting. For us as a vendor, there's two things that came out of it. One was um, customers wanting to run game days with us. So, and this is something that we recommend as well, which is don't wait till disaster to exercise that failover. Do it proactively, do it at some frequency. And that in the context of actually simulating an outage is what we would basically call a game day. It's kind of like, the notion of security tabletops or sort of DR drills, etc., right? But a different word, I suppose. And these are days where we go in and we simulate failure. So as an example, every temporal cell runs in 3 availability zones.
Easy. It's not regions, but easy.
Right? By default, every customer gets that level of availability. And so one game day that we run is just simulate a single AZ failure and make sure that there is absolutely no impact to customers, right?
So these AZs are all behind a load balancer?
These AZs are all sort of part of the core infrastructure.
Oh, it shares.
Yes.
Nice.
Yes. So customers don't see them. They're only exposed to the logical concept of the namespace, and we handle all of the high availability underneath.
And AZs generally are in the same region or multiple regions?
So there are two configurations you get. So when you use temporal and you build a namespace, by default, every namespace runs in 3 AZs in a single region.
Single regions, okay.
And then you can go into our UI and or command line or API, and you can say, I want multi-region. And that's where you can then replicate to another region.
That makes 4 or 3. It's
That-
all quite a different.
3 in 3, right?
Oh, I see.
And then you can also, if you wanted to have cloud failover, we also allow replication between, for instance, AWS and GCP and vice versa. So we have a fairly deep sort of high availability story here. And, going back to one of the other things that happened along with game days is as customers really sort of woke up and as you can imagine, boards across the country are asking this question of what happened.
Yes.
It's personal because we actually had a board meeting the next week after the outage, and this was the first question that we got asked is how did temporal do? But as this started happening, we have seen the number of customers using this multi-region capability on temporal has doubled since October. And you can imagine, Q4 is a time where customers typically don't touch their infrastructure.
Yep.
So you can imagine how important this topic became and also how simple the multi-region capabilities, if you were already using temporal, they're so easy to use. We were able to double the customers using it so quickly.
It is easier always said than done when it comes to reliability problems, right? Especially when you have multiple AZs. I think in my mind, having data in 2 regions with that like a 1 minute delay itself is as an architectural like miracle in my mind, right? How did you manage to get this going?
This replication stack has been in temporal. In fact, it's in open source, and some of our
Temporal open source.
yes,
Okay.
yes, and so what we are able to do with temporal cloud is really enable it to operate in a much easier way. But the technology has been part of the core temporal open source project since very early days.
I see. I have had a few such events, and it was never easy, one, to figure out where the points are. Second, to find out the list of things that you need to do to get here. Third, getting an alignment from an organization standpoint.
Right.
Because this is not something that people would realize that would happen one day. And once it happens, it's not going to be a quick fire drill, right?
Right.
How did you establish that culture that everybody's thinking about this and people are aligned and now I can march towards it?
I think the main thing to understand is temporal as a platform exists to be able to help developers offload their reliability problems, right? Because the paradigm shift with temporal is you focus on your business logic. We take care of all of the error handling, retries, crashes, all of that, right? And so to answer your question, it's around just reliability is the product's core value. And if we don't live it in how we interact with each other, how we build our systems, how we respond to our customers, then, we are not being true to our product's core value. And we just can't be successful if you're not true to the value that you're providing, right?
Now, tell us a little more about the outcomes at the customer side. A fire hydrant, I heard, has had pretty strong reliability culture built after the incident or around it? Tell me more.
Yeah, so Fire Hydrant actually is really interesting. They are in the business of actually alerting, right? So when incidents happen, they need to be up and running because that's how the on-call people are made aware, right? And so they were one of those customers that was actually ahead in the sense of they had already started using the multi-region failover capabilities. And so they were ready. They had done fire drills around this. And when the incident happened, they were able to go in, fail over, not skip a beat. We wish more customers thought about reliability early. One of the interesting things we are seeing is one of our customers is sort of is in the business of sort of being a commercial around big events. And so they are looking at enabling multi-region failover whenever a big event is going to happen, right? So, Super Bowl is coming up next week, for instance. How can I enable multi-region failover just in time to make sure my business is secure during like this key meaningful event for me? So we're starting to see some sophistication emerging, not just around being aware, but also sort of situationally and time-based, and when I really, really need to make sure that nothing fails.
So for customers or for engineers who are trying to really think about this, like design this, right? What is your 5 things that you would ask them to do first?
First, I want to just acknowledge it's a huge responsibility and we take it incredibly seriously. In terms of engineering principles, how we think about this and how we sort of work with our teams, one is you have to assume failure is going to happen, and failure can happen at any level. And so, as you do your design blueprints, you need to be able to do all the kind of gaming around where failures can happen and what happens to your design when these failures happen, right?
So it
that's
starts
one.
with design first.
Starts with design. The second part of it then is as you're building this, how can you make sure as part of that sort of the redundancy pieces, how do they where do you need to rely on them heavily? And then what are the trade-offs you're making around cost, latency, performance, and redundancy, right? So we have established sort of a framework around all of these dimensions.
I
And
see.
where do you need to fit for which critical path pieces that absolutely need to be reliable no matter what versus where you can take some delays, right? So for instance, even with temporal, we talked about earlier the concept of the customer's traffic versus the control plane. Right. So being very educated about those. And then of course a ton of testing. As things are coming live, we test a lot. We follow a ring-based, cell-based approach around deploying and making sure that as a change is moving through, we are monitoring very closely all of the system characteristics to see what's the impact of this change.
And we have a way to roll back if
Yes,
okay.
absolutely. And then one of the principles as well that we throw in here is reliability over features, reliability over margins. There have been times in the last, I would say, 12, 18 months where we've said, let's throw some more capacity at this. It's okay to take a margin hit, but you never, ever take a reliability risk. So those hopefully help, some of the principles we think about. Yeah.
I think that culture shift helps, and
Yes.
I'm sure customers are already seeing the outcomes of that culture shift. When it comes to this reliability incidents, architecture is one part, culture is the other part, and making sure that everybody is aligned, right? So there has to be an alignment that, okay, you know what, I don't want to really fight this every day.
Yeah.
This is now part of the culture and it's part of the checklist.
Yeah.
So if something is coming out, it has this check box on.
Yeah.
So how do you make sure that for new leaders, how do they establish it?
I would say there's a few things to be really careful about. One is you have to set the tone, set the tone early, and you have to model it, right? And so the fact that I personally get paged, the team notices that I join these incident channels. And, oftentimes I cannot help with the technology, but just me being there sets that tone around this is really important, this matters, right? So I think that that's part of it. The second part of it is, again, just normalizing this and repeating, for instance, we've written this down as a value. The other thing we do is we share metrics around how many incidents, how we're doing, how much better we're getting. And one of our most attended sort of rituals is every other week we do a root cause analysis kind of postmortem meeting internally that is open to the entire company. It's a blameless forum where we pick, like, a couple of incidents that are interesting to talk through. And everyone from the intern to the CTO to the CEO joins that meeting. And we basically talk through what information did the individual have, what could we have done better in an incredibly blameless way.
Now, for anybody who's probably starting this journey or starting to really build this culture, what are the steps for them to really get started, right? So this is where you should start with the alignment. This is where you should start with the execution, and this is the outcome that you get.
I think in terms of starting with alignment, it is really important to understand why you want reliability, right? Like, I feel like, especially now, we were chatting about AI and code, and there is so much code being written with such incredible speed, which is fantastic to see. But if that code isn't reliable, are you delivering the customer experience you want, right? So the I guess the first alignment thing that I'm trying to articulate is, like, it's not reliability for the sake of it. It's about why do you care, right? And once you establish the why do you care, then being very clear with your teams about the impact of not being reliable. And really, it's not talking about I need an SLA of X. It's more what happens if you don't have that SLA, and how are you letting down your customers, right? So to me, alignment starts with that. And in terms of execution, it's about constantly asking the question around what happens if, right? What happens if this breaks? What happens if you get a DDoS attack? And
Does a chaos monkey help?
of course, best practices, principles, baking it into your sort of development practices. Absolutely. I feel like the industry has made a lot of progress here, right?
Yeah, there is a lot.
Yes.
In fact, now things are a lot easier, a lot better. Even the load balancers inherently, they have changed their way they approach this problem. It's a lot better, a lot safer, but still, again, as I said, I mean, this will happen for
Yeah.
sure, right? It's not if, it's when. Perfect. Thank you so much, Preeti, for sharing all these hard earned lessons with us. And this was excellent. I'm sure we have a lot to take away from this conversation and implement in our companies. Thank you.